So now we're going to move on to example number 11. Time does permit. So let's take a look at this. And this is actually a really, really interesting question that highlights some really kind of weird things that happen with certain functions. We've seen a lot of weird functions thus far this semester with all these crazy new piecewise functions with a whole bunch of, jumps and gaps and breaks in them. But this function is particularly curious. So we just want to simply figure out where this function is continuous. And so we can start by, again, kind of taking a look at each individual piece that we have here. We notice that, again, y equals the natural log of x, so a natural log function, is continuous on the interval from 0 to infinity, not including 0. Remember that you can't use any negatives inside of a natural log, or really any logarithm, and you can't use 0. So only things that are positive. So notice that we can also say, though, that y equals 1 minus the cosine of x is always continuous. So that means that we're working there with the interval of negative infinity to infinity. So the only issue right now is if 1 minus the cosine ever produced a value that's negative or produced a value that's 0, right? Because if that happened, then I would have a 0 or a negative number on the inside of the natural log, and I would fail to be continuous. So what we can start to see, though, is that it's actually not going to be possible for this inside sort of function to actually create a negative number, right? So I can state here, we see that 1 minus the cosine of x is always going to be greater than or equal to 0. That's always going to be the case. But if it equals 0, then the natural log becomes undefined. So what we have to figure out is where are all of the times when 1 minus cosine would be equal to 0. So we can see that 1 minus the cosine of x will be equal to 0 whenever the cosine of x equals 1. And of course, I could start to think here, when does the cosine of x actually end up equaling the value of 1? Well, let's see. Can you come up with any angles? What would be some different values that would make this equal to 1? Well, 0 is a value that comes to mind. Technically, you could also say 2 pi. You could say 4 pi. In fact, you could kind of keep going, right? There's lots and lots and lots of values. You go to 6 pi and 8 pi and 10 pi. Really, any even multiple of pi is going to work. But you could also go ahead and actually state that positive and negative of these values is going to work. So at all of these values, the cosine is equal to 1, which means that 1 minus the cosine is 0, which means that the natural log of that is going to become undefined. So we can actually conclude that f of x is continuous at all values except x equals 0 plus or minus 2 pi plus or minus 4 pi plus or minus 6 pi. And hopefully you can kind of see where the pattern's going here. I'd go to 8 pi, 10 pi, all those even multiples of pi. But it is continuous, again, everywhere else, everywhere between those. So what's kind of crazy here is to actually just note what this kind of implies. So what this means is that f of x actually has infinitely many discontinuities. How crazy is that? It actually has infinitely many discontinuities in it that endlessly breaks apart. It's almost worse than one of those piecewise functions that only broke apart, 3 or 4 times, right? This one breaks apart infinitely many times. So we can see some really, really weird functions can start to be created, and we can start to understand using the theorems how quickly we can get to determining where functions are continuous and where they are discontinuous.